Before BMW built engines like the M54, there was another engine to speak of. They built this, the M30. If I asked you to name BMW's most reliable engine, what would you say? The M50? The M54? Maybe the modern B58? They're all good answers. But sadly, they're all wrong. BMW's most reliable engine isn't a double overhead cam 4-valve wonder. It doesn't have VANOS. It doesn't have Valvetronic. It doesn't have variable valve timing of any kind. It's a single overhead cam, 2-valve, cast iron straight six that BMW built for 27 years. And some of them have done over 500,000 miles on the original bottom end. This is the story of the engine that BMW call the M30. The engine that proves BMW always knew how to build something that lasts forever. They just chose not to. In the mid-1960s, BMW was a very different company. They'd nearly gone bankrupt in 1959. They'd been saved by Herbert Quant's investment, and they were rebuilding their reputation, one model at a time. The BMW New Class saloons and sedans had established that BMW could build excellent small cars. But BMW's leadership knew they needed to move upmarket. They needed a bigger car, a luxury car, something to compete with Mercedes-Benz. And a luxury car needed a luxury engine. BMW needed a straight six, smooth, refined, and powerful enough for a large saloon or sedan vehicle. And above all else, reliable. BMW's chief engine designer, Alexander von Falkenhausen, was given a clear mandate. Take the proven architecture of the M10 4-cylinder and extend it to 6 cylinders. Keep the cast iron block. Keep the forged crankshaft. Keep the overhead cam with rocker arms. Keep everything that made the M10 reliable and simply add 2 more cylinders. No revolutionary technology, no cutting-edge materials, no untested designs. Just take what works and make it bigger. That philosophy, proven, conservative, over-engineered, would define the M30 for the next 27 years. The M30 uses a cast iron cylinder block, not aluminium, not magnesium-aluminium composite like the N52. Iron. Cast iron is heavy. It adds kilograms that aluminium doesn't. But it has properties that aluminium can't match. It's harder, which means cylinder bore wear is minimal even after hundreds of thousands of miles. It's more rigid, which means the block doesn't flex under load. And it handles heat brilliantly. Cast iron absorbs and dissipates thermal energy without the warping that aluminium is prone to. When BMW engineers chose cast iron for the M30, they were making a deliberate trade-off. They accepted the extra weight in exchange for decades of durability. The M54's aluminium block might be lighter, but the M30's iron block will outlast it by a factor of 2 or more. Where the M50 has dual overhead cams and 4 valves per cylinder, the M30 has a single overhead cam and just 2 valves per cylinder. 12 valves in total for the entire engine. This is half the valvetrain complexity, half the moving parts, half the things that can wear out, go out of adjustment, or fail. The M30 uses rocker arms actuated by a single camshaft with mechanical valve adjustment. No hydraulic lifters to tick or fail. No VANOS to develop solenoid issues. No Valvetronic eccentric shaft sensor to trigger warning lights. Just a cam, rockers, and valves. Simple. Yes, mechanical valve adjustment means you need to check and adjust the valve clearances periodically, roughly every 15,000 miles. But this is a feature, not a flaw. It means a mechanic regularly inspects the top end of the engine. Problems get caught early, and the adjustment procedure takes about an hour with basic tools. The M30's bottom end is where BMW's over-engineering becomes legendary. The forged steel crankshaft is massively oversized for the loads it handles. The connecting rods are forged steel. The main bearing caps are substantial. Everything is designed with enormous safety margins. This is the philosophy of building a bridge. You don't design it to handle exactly the load it will carry. You design it to handle 3 times that load. The M30's bottom end can handle far more stress than BMW ever asked it to endure in standard tune. That's why these engines survive hundreds of thousands of miles, because they were never working hard in the first place. Many modern engines use timing belts, rubber belts that need replacing every 60,000 to 100,000 miles. Miss the replacement interval and the belt snaps. On an interference engine, that means catastrophic valve damage. The M30 uses a timing chain, metal, durable, with a hydraulic tensioner that automatically maintains correct tension. These chains routinely last 200,000 plus miles. Some M30 chains have lasted the entire life of the engine without replacement. Early M30 engines used carburetors. Later versions used Bosch L-Jetronic and then Motronic fuel injection. But even the fuel-injected versions used relatively simple mechanical fuel delivery compared to modern direct injection systems. No high-pressure fuel pumps to fail. No direct injection carbon buildup on intake valves. No piezoelectric injectors that cost hundreds each to replace. Just port injection that mixes fuel with air before the combustion chamber, keeping the valves clean for the life of the engine. The M30 first appeared in 1968 in the BMW 2500 and 2800 saloons and sedans, the E3 series. These were BMW's first luxury saloons and sedans, designed to challenge Mercedes-Benz on their own turf. From there, the M30 went everywhere. The E9 Coupe, the gorgeous 3-litre CS and 3-litre CSI that are now worth 6 figures. The E12 5 Series, BMW's first proper executive saloon. The E24 6 Series, the 633 CSI and 635 CSI Grand Tourers that defined elegant motoring in the 1980s. The E23 7 Series, BMW's flagship, their direct answer to the Mercedes S-Class. The E28 5 Series, including the legendary 535i that became the driver's executive car of the mid-80s. The E32 7 Series, which used the M30 right alongside BMW's new V8 and V12 engines. And finally, the E34 5 Series, the 535i that kept the M30 alive until 1995. Think about that for a moment. One engine architecture, from the late 60s to the mid-90s, through fuel crises, emissions regulations, changing safety standards, and 5 generations of cars. The M30 adapted, evolved, and survived them all entirely. It was offered in 2.5-litre, 2.8-litre, 3-litre, 3.2-litre, and 3.5-litre versions. Carbureted and fuel-injected, with and without catalytic converters, for markets from Europe to North America to the Middle East to South Africa. No other BMW engine has served in so many models, across so many years, in so many markets. The M30 is BMW's most prolific engine, and that's not a coincidence. You don't keep building something for 27 years unless it works. Here's where the M30 story goes from impressive to genuinely extraordinary. On BMW enthusiast forums, there's a culture around high-mileage M30 engines. Not a support group for people dealing with problems, a celebration of engines that simply refuse to die. Ron W.'s E28 535, 350,000 miles on the original M30. Jim's 533, 485,000 miles. Original bottom end, never rebuilt, still running. In the Middle East and Africa, where E28 and E34 BMW models served as taxis, the M30 regularly exceeded 500,000 kilometers. In some cases, these engines ran for over a decade in continuous taxi service, driven hard in extreme heat, often with minimal maintenance, and they survived. Compare that to the N52's water pump that fails at 60,000 miles. Compare it to the N54's high-pressure fuel pump recalls. Compare it to the N63 V8 that BMW themselves nicknamed the Hot V because it cooked its own turbochargers. The M30 doesn't just survive. It makes modern BMW engines look fragile by comparison. And it does it with technology from the 1960s. So why do these engines last so long? It comes down to three things. First, over-engineering. Every component was built with margins that modern cost accountants would never approve. Second, simplicity. Fewer parts means fewer failure points. And third, maintainability. The M30 was designed so that anyone with basic tools could maintain it. Valve adjustment with a feeler gauge. Oil changes that take 20 minutes. No specialist diagnostic equipment required. The M30 wasn't built to be exciting. It was built to be dependable. And in doing so, it became something more exciting than any turbo or variable valve timing system. It became hugely legendary. And this is the part of the M30 story that should make every BMW owner uncomfortable. BMW knew how to build engines that last. The M30 proves it. 27 years, 500,000 miles. Cast iron, forged steel, simple valve trains, conservative engineering. They knew the formula, and they chose to walk away from it. Every decision BMW made after the M30 moved in the opposite direction. Aluminium blocks instead of iron. Double overhead cam instead of single overhead cam. Hydraulic lifters instead of mechanical adjustment. VANOS, Valvetronic, direct injection, electric water pumps, magnesium, plastic. Each step added performance. Each step added efficiency. Each step met stricter emissions standards. But each step also added complexity. More things to go wrong. More expensive things to go wrong. And shorter service lives. Was it worth it? That depends on what you value. If you want maximum performance from the smallest, lightest package, then absolutely. Modern BMW engines are engineering marvels. The B58 makes more power from 3 litres than the M30 made from 3.5, with better fuel economy, lower emissions, and a broader power band. But if you value longevity, if you value the ability to fix your own car, if you value an engine that asks for nothing except oil changes and valve adjustments, and then rewards you with decades of faithful service, then the M30 is the answer. And no BMW engine since has even come close. The M30 teaches us a lesson that the automotive industry has been ignoring for 30 years. Sometimes, the best engineering isn't about adding technology. It's about having the discipline to leave it out. Wards named the M30 one of the top engines of the 20th century. Not because it was the most powerful, not because it was the most advanced, but because it was the most enduring. An engine that did its job brilliantly for almost 3 decades and asked for almost nothing in return. Every M30 still running today is a monument to what happens when engineers build for durability instead of spec sheets. When they choose iron over aluminium, simplicity over complexity, and longevity over lap times. BMW could build an engine like this again. They have the knowledge, they have the capability, but they just won't. Because the market demands lighter, more powerful, more efficient engines every year. And the M30's formula, heavy, simple, conservative, is the opposite of what sells in 2026. So the M30 stands alone, sadly, the last of its kind. BMW's most reliable engine, and also its most simplest engine. Those two facts are not a coincidence. This is where the reputation started. Now here's where it peaked. Next time, we're asking a question that goes beyond just BMW. What happened to the soul of the Inline Six? Why does a modern turbocharged straight six, no matter how powerful, feel different from a classic naturally aspirated one? Is it just nostalgia? Or did we actually lose something that engineering can't get back? The Inline Six that modern BMW can't recreate. If you want more untold stories about the engines, transmissions, and regulations that shaped automotive history, please do join us and subscribe. Thank you.